Welcome back. The video today is an introduction to the physical and chemical processes in what's called traditional water treatment. So you might take water from a source, probably a surface water source, and then the processes you go through to make it prepared to drink and to use. So it's a pretty quick video. I just want to talk about the processes. In our course this semester, we're going to focus on one of the later processes called filtration, and that would have been the focus of our project in the lab. In the spring, we're going to go back, hopefully, in the lab, and we'll look at the entire process. So let me share my screen with you and we'll get started. Okay. So this is water treatment. So water treatment usually is an industrial scale process that you try to make the water more acceptable for whatever the end use is. One of the end uses is us. Every time you go to the faucet, get some water for cooking, for drinking, for washing. This is treated water. This had a lot of processes done to it to make it safe for you to consume. So as you can see, one of the key uses is drinking water, and that's our focus today, but it can be industrial, municipal, or any other number of uses. So the goal of all water treatment is to remove existing contaminants and to reduce the concentration of those contaminants so that the water is desirable for whatever the end use is. And also, once you finish with the water, it would be to return that water to a natural environment without adverse impacts. Now, that would be called wastewater treatment. That can be a much more complicated thing. If you can imagine all the things that you flush down the drain or flush down the toilet, those things have to be removed. Whereas in a normal water supply source, it's not necessarily as critical. So this is a schematic on the right-hand side of a typical water treatment system. So the four basic processes in water treatment are what's called coagulation and flocculation. And then that leads into what's called sedimentation. And then filtration. As you can see, filtration, that's the focus of our project. This time it'll be the focus of really our talks or the videos that come after this. And then disinfection. So let's talk about these initial processes. So let's talk about what coagulation is. So what happens is you'll have your water coming in from some intake. Here you can see it's a surface water source, a reservoir, a lake, a river. I will tell you that here in Memphis, we don't take our water from the Mississippi River, thank goodness. We have one of the nicest underground water supplies probably in the world called the Memphis Sands Aquifer. There'll be a video next week talking about the history of this aquifer system and how we use it. We're very, very fortunate to have such a clean and plentiful supply of water for many, 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 many generations. And the treatment that we need for this water is minimal compared to what we're talking about today. But typically, a lot of systems have surface water sources, so they'll take it from that intake. And the first process is called coagulation. Now, coagulation, you're probably familiar with coagulation from like when you have a cut and you bleed. You hope that your blood cells will coagulate, which means that these small particles will start sticking together and form larger and larger aggregate particles, and that those particles, for the bleeding scenario, will plug the hole and keep you from bleeding to death. We have a similar situation here in water treatment. So what we want to do is, one of the main sources of contaminant in surface waters is suspended material. So again, if you were to go down the Mississippi River and get a big scoop of water, let's say a glass, and look through it, you'd see a lot of suspended material that's floating in the water. And if you let it sit there long enough, some of it will settle to the bottom, but a lot of particles will not. They're so small that they will stay suspended and we won't be able to get them out. So what this coagulation process does is chemically, it helps these small particles stick together and form larger and larger and larger particles. We call this flock. And these larger flock particles then gain enough mass that they will fall out in a sedimentation system. Now, flocculation is a system, mechanical system, where these chemically altered particles, the stickiness has been added to them. It gives them a chance to bump into one another. It's a very gentle process. There is some mixing, but again, it's very gentle. We're trying to nudge all these particles that they collide. And as they collide, they'll stick together and form those larger flock particles that we talked about earlier. So the mixing of the initial chemical can be very violent. You want to get the chemical well distributed. But in the flocculation part, it's very gentle. Now, once these particles have formed are larger, these flock particles, these aggregate particles, then they pass into the sedimentation system. And what sedimentation tanks typically are very large tanks where the water is brought in and it moves very slowly. And it gives lots of opportunity for these large particles, these aggregate heavy flock particles, to then just by gravity sink to the bottom of the tank where they can be scraped away and removed. So that's one classic way of removing suspended material. Now, some you just can't do. Some particles escape the system. Some particles don't necessarily flock together well enough for sedimentation. So we then run it through a final filter stage. These filters are usually beds of granular media, small crushed rocks, and anthracite coal, and of various sizes. And as the water flows through these fine openings in the granular media, the sands, they get stuck in many different ways. One of the videos that comes after this will talk about the mechanics of filtration. So hold your questions till then. So that will trap a lot of this suspended material that was not removed by sedimentation. Then finally, when the water exits the filter, it's very, very clear and removed most of the suspended material. In fact, the EPA requires a very, very low measurement of what we call turbidity, which is a measurement of that suspended material. The final step is disinfection. Again, the EPA requires us to add chlorine as a disinfectant to kill any kind of bugs or pathogens. And also they require fluoride for your teeth. And many water supply systems add an additional chemical to help stabilize any kind of flaking or rust in the pipes. That's the final step. And after this, the water is usually put into a distribution system, elevated tanks or underground tanks, and then depending on demand, the water system will pump the water to service our needs. Especially in the morning when we wake up, we use a lot of water. And then late in the afternoon, those are our two peak times. So again, coagulation, flocculation, sedimentation, filtration. In the lab, we would simulate those four components. You would then have disinfection, fluoridation, and stabilization. That's the pipe chemical I was talking about. And finally, you would take samples and make sure everything is going well. And Memphis Light, Gas, and Water has a lab actually very near the campus. And that's where a lot of the water samples go for testing. So again, let's just summarize. So coagulation, you add different kinds of aluminum or iron salt chemicals or polymers, and these help the particles stick together. And the flocculation is a slow mix process to cause these particles to collide together and then chemically stick. And these larger particles then will have a chance to flow into a tank and then settle to the bottom. That's sedimentation. And then finally, you pass through the effluent of all of those systems. Well, I'm using terminology I forgot to define. Influent is the water that comes into a process, and effluent is the water that comes out. So as we go into the sedimentation tank, that would be the influent. Then it goes to a settling process. Then the effluent of that tank is the influent to the next process, which would be filtration. And then, of course, we have disinfection. Chlorine is usually added to kill bacteria and other diseases. Fluoride for benefits for your health, dental health. And then stabilization, small amounts of sodium hydroxide or other chemicals to help corrosion in all the plumbing. And then finally, we collect our samples. So hopefully that's give you a little introduction to what water treatment is, so just some basic terminology. So you'll probably follow this with the next video, which is right after this, which will start talking about a little more details about filtration. That'll be the focus of our discussions this semester. So if you have any questions, as always, please let me know, email me. We can have a Zoom meeting if we need it. So until next time, please be safe and take care.